Okay, now we're going to talk about the information gain. Information gain is the decrease of entropy after a dataset is split on attributes. Okay, so this is the formula. Information gain of set A, attributes A, information gain of a set S, comma, attribute decrease by attributes A equals to entropy for the whole set minus the sum of the proportions of the value from the whole set multiplied by entropy of the value itself. Okay, value is element of the value of attributes A. A is an attribute as its sets, as V is the subsets. Okay, so for Group 2 discussions, you need to conduct mini research on what is information gain, what is entropy, and why decision tree use these metrics. Okay, we use these datasets to apply our ID3 algorithm. Okay. Now we need to calculate, first step in decision tree is to calculate the whole entropy. So we have 9 positive data, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 5 negative. So the entropy formula is minus, and then this is the probability of these positive. This is the probability of negative. Okay. So how to calculate this is easy. Minus 9, because this is 9, out of 14, the whole dataset is 14, multiply by log base 2, 9 out of 14, 5 over 14, multiply by log 5 of 14 equals to, so this is the whole entropy. Next step is, okay, calculate the information gain, because we want to pick the attribute with the highest information gain to be put as the decision tree, as the root. Okay, so this is our node. Okay, so we use this formula. Information gain equals to entropy for the whole set. We already discussed about this before. Minus the probability of the humidity when it's high, the value, the subset of value, multiply by entropy when the humidity is high, minus the humidity when it's normal, multiply by entropy of humidity of normal. So we need these two first. Okay, we need this and this. We already have this, and this is just easy. Okay, how to calculate entropy of humidity is equal high is something like this. So we divide the humidity attributes into two subsets. Subset 1 is when the humidity is high, and subset 2 is when the humidity is normal. Okay, so we have the subset when the humidity is high and normal. In high, we have 3 positive label and 4 negative label. Here we have 6 positive and 1 negative. So intuitively, based on this entropy hyperbolic curve last time, remember, this is the highest, this is the lowest, this is when you have all negative or positive, and this is when you have equal between negative and positive. So based on this, 3 and 4, this is probably higher. 6 and 1, this is homogeneous, so it's probably lower. That's correct. Based on this formula, we can have 0.9 for high and 0.5 for normal. Okay, how to calculate this is just using the previous formula. 3 out of 7 because this is 3 out of the whole subset. The humidity high is equal to 7. And then multiply by log base 2, 3 over 7. So this is for positive, and this is for negative. Yeah, the same like this for the humidity when it's normal. Okay, and then after we have entropy, and entropy of the whole set, and then we can calculate the information gain. Information gain of S on attribute humidity equals to, this is the entropy for the whole set, entropy of S, minus 7. Why 7? Because when the humidity is high, this is 7. Yeah, equals to 7. Out of 14, 14 is S, multiply by this entropy of humidity is high, minus 7 out of 14, this is 7 as well. Out of 14, 14 is S, and then multiply by the entropy, this one. Now we have the information gain, 0.151. Okay. Then the next step is we repeat the same step for each attributes. So we have how many attributes? We have humidity, we have wind, we have temp, and we have outlook. 1, 2, 3, 4. So we need to repeat again until we can calculate the gain. Alright? 0.151, 0.048, the same way to calculate the information gain and entropy. After that, we're going to see which attribute has the highest information gain. Okay, so this is the final calculations of our gain. Gain of outlook attribute is 0.246. This one 0.1, 0.04, 0.29. So we pick the one with the highest information gain will be used as the splitting attribute. So we pick this as the root. Outlook. How about the next one? What is here? What is here? What is here? We need to repeat again the whole process with the subset of this one, with the subset of this one, with the subset of this one. This one is for sunny. This is for overcast. This is for rain. Repeat the whole formula, the full process, but only for the subset, and then we can build the trace. Okay. And then finally, we can have the decision tree, complete decision tree like this. Outlook is our highest information gain, 0.246 is chosen as the root. And then what next? Outlook equals sunny, outlook equals overcast, outlook equals rain. This is straightforward. The leaf is yes, that is the leaves. And then what next after this? When the outlook is sunny, we have humidity here as the highest information gain. Okay, and then this one is when the humidity is high, when the humidity is normal, and this one is when the wind is strong, wind is weak. Okay, how to interpret this decision tree is easy. When the outlook is sunny and humidity is high, then the decision is no. When the outlook is overcast, we don't care about any other attributes, we play tennis. Yeah, something like this. So, if we were given the new data set like this, the outlook is sunny, the temperature is hot, the humidity is high, wind is weak, whether we are playing tennis or not, we can see our model. This is our model. We can check in our decision tree. Outlook is sunny. Okay, outlook is sunny. Temperature is hot, it's not here. We can just ignore this. And then humidity is high. Okay, my humidity is high. Okay. Okay, now my decision is, according to my trace, my decision is no. So we put the prediction label here as no. Okay, so this is the discussions. Conduct a mini research on advantages and disadvantages of decision trees. When do you think decision tree will be better than any other method? And then work with your own data. Find a small toy datasets to explain how to predict on decision tree using your toy datasets. And this is your class mini exercise using the play tennis datasets. You need to determine the whole value of this. Entropy when outlook is sunny, entropy when outlook is overcast. You need to fill in up all these tables. And then what happened next? If you split on attribute outlook, because outlook has the highest information gain, so you also need to know every calculations. Then you can draw your tree based on the entropy and gain calculation. Okay, that's it for the explanation on decision tree. One more explanation on why we use entropy. Okay, here. So if we see, the entropy is like this, right? This is the equal value. This is the homogeneous value. Okay, why we choose the highest information gain? What does mean? The highest information gain equals to entropy from the whole set minus the entropy of the attributes, right? Okay, so when we see something like this, the entropy of the whole set is the same. But when the entropy here goes down, okay, we choose the highest information gain, right? This is fixed minus something that is variable, can be up, can be down. So what happens if the entropy of attributes A is lower? Then the information gain will be higher. And the other way around, if the information gain is, if the entropy of A is higher, then the information gain is lower. Right? Because you subtract the fixed value with the big value. So you left with a small number. But here, if we subtract the fixed value with the small number entropy label, you will have a very big information gain. So basically, decision tree wants the highest information gain, means wants the most homogeneous data. Or lower entropy. Why? Because it's easier for us to draw the decision like this. Straightforward. If the outlook is overcast, we don't care about the other attributes. We straight delete straight to the decision. which is yes, we play tennis.